Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. The night settles around you like a quiet, weightless veil, and as you listen, as you let the edges of your thoughts soften, a gentle question begins to drift into focus. What if the universe around you is not continuous, not smooth, not an unbroken flow of substance and motion, but something far more delicate, far more structured, far more quietly mathematical? What if everything you see, everything you feel, everything you call reality, is built from tiny units of information, bits of cosmic code, woven together to create the world that cradles you now? The thought comes slowly, like a ripple moving across a still lake at dusk, never urgent, never sharp, just present, quietly unfolding. You are here, listening, and the world around you is resting in its own subtle way, a world where starlight travels across unimaginable distances, where atoms vibrate with patterns so ancient they echo from the birth of matter itself, and where each moment, even this one, is part of an intricate structure that science is still learning to read. Tonight, we drift into that structure, softly, without resistance, without hurry. The idea that the universe may be built from information is not mystical, not metaphorical, but deeply scientific and deeply calming when approached with the slow rhythm of curiosity. Information, in physics, is not a story we tell, but a measurable quantity, as real as energy, as fundamental as mass, as present in every physical process as the gentle flow of time. When scientists speak of information, they speak of distinctions, of yes and no, of presence and absence, of patterns that can be counted, stored, transformed. A bit in computation is simply a choice between two possibilities, a 1 or a 0. Yet the universe, with its deep structure of quantum events, seems to speak in its own version of bits, small decisions, tiny binary outcomes, moments where nature chooses between alternatives, not continuously but discretely, one event at a time. And so as you settle deeper into this moment, your mind can wander toward that gentle idea that beneath everything, beneath every particle, every star, every whisper of light, the universe might be counting, measuring, distinguishing, storing, updating, as if reality itself were a quiet computation, running softly in the background of existence. But before thought becomes complex, before ideas branch into deeper questions, there is the simple feeling that comes from imagining the universe as a vast informational ocean, a place where patterns move like tides, where structure rises and falls like quiet waves, where nothing is wasted and nothing is lost, only transformed. Information, in this sense, is not noise, not disorder, but the very opposite, a kind of cosmic clarity, a structure that shapes everything. Your thoughts this evening, your memories, your dreams beginning to form in the background, all of them are patterns of information flowing through the architecture of the mind, electric signals whispering in neural pathways, binary-like firings combining to create feelings, impressions, and images. And outside you, through the silent air, the universe works in its own informational patterns as well, its quantum fields fluctuating, its particles exchanging data about their states, its structures evolving with every passing instant. You are surrounded by information, immersed in it, shaped by it, made of it, not metaphorically, but physically. As you drift deeper, you may notice how calming it feels to imagine the universe as something orderly, something that follows rules, something that unfolds according to patterns elegant enough to be written down, studied, understood. The laws of physics, those quiet principles that govern everything from falling leaves to spinning galaxies, can be thought of as the rules of a cosmic program. A set of instructions that guide how fundamental pieces of reality interact with one another. Not because the universe is artificial or simulated, but because information, by its nature, requires rules, requires structure, requires a language in which distinctions are made and patterns are allowed to grow. And so reality becomes a tapestry woven from informational threads, threads that are both simple and profound. Threads that connect the behavior of the smallest particle to the arc of the largest galaxy. Threads that connect you to the world around you in ways more intricate and beautiful than a continuous universe ever could. When scientists speak of quanta, they are describing discrete packets of energy, units that cannot be subdivided beyond a certain point. This discreteness hints at something deep, something foundational, something quietly digital. A quantum event is a kind of yes or no choice encoded in the universe itself. A photon is emitted or it is not. An electron spins up or down. A field fluctuates one way or another. Tiny decisions, tiny distinctions, tiny informational states, billions upon billions of them occurring everywhere, every moment, forming the structure of reality, one measurement, one binary choice, one whisper of difference at a time. It is soothing because it suggests the universe is not chaotic, not disordered, but precise, organized, quietly logical. Even when things feel unpredictable, even when nature behaves in ways that seem wild or strange, the underlying processes follow consistent rules, subtle rules, rules that science continues to uncover. And in that uncovering, there is a feeling of clarity, a sense of peace, because every new discovery reveals another layer of the universe's informational structure, another part of the quiet code beneath everything. As your thoughts grow lighter, less tethered, you may sense how natural it feels to allow the concept of information to become the foundation of reality in your mind. Matter, energy, forces, fields, all of them emerging from distinctions, from patterns, from encoded rules that determine how the universe evolves. In this view, reality is not a continuous flow but a sequence of discrete states, each one giving rise to the next, each one updating the cosmos in tiny, incremental steps, a cosmic computation running at every scale. Yet this computation is not mechanical, not rigid, not cold. It is elegant, subtle, intricate, and beautiful, a structure that cradles galaxies and gives birth to particles with the same underlying logic, a structure that supports life, consciousness, awareness, and the quiet moment you are living right now. Patterns fill the universe with meaning long before the human mind learns to interpret them. Snowflakes form with perfect geometries guided by molecular interactions that themselves follow informational rules. Crystal lattices grow with repeating structures that reflect the atomic codes embedded in matter. Even the genetic material in living cells is structured as information, encoded in base pairs, read by molecular machinery, copied, stored, and expressed within the most delicate chemical arrangements. Everywhere you look, the universe is arranging itself through informational principles, through discrete states that accumulate into larger forms, through rules that give rise to everything from minerals to mountains to minds. This is the quiet strength of seeing reality as information. It transforms the world from something merely material to something deeply ordered. A world where complexity grows naturally from simple conditions, where structure emerges gently from foundational distinctions. It lets you rest in the thought that the universe knows what it's doing, because its code is consistent, its rules are elegant, its information is preserved and transformed in ways that maintain the harmony of the whole. As you drift further into this calm understanding, you may notice a soft sense of wonder spreading through you, a curiosity that doesn't demand answers but enjoys the feeling of being wrapped in mystery. The idea that reality could be digital is not meant to simplify the universe or reduce its beauty, but to highlight how wonderfully structured it is, how balanced, how sensitive to the tiniest distinctions, every particle interacting according to quantum rules, every photon carrying information across cosmic distances, every field updating in discrete transitions. The universe becomes a quiet library of informational states, each one building on the last, each one contributing to the cosmic story. And here you are in the midst of it, a conscious pattern within a larger pattern, a luminous ripple in a vast informational ocean, resting, listening, drifting, while the deeper rules of nature continue their calm unfolding all around you. The night holds you, the universe holds you, and the thought of reality as information becomes softer, more natural, more peaceful, not a theory to solve, not a puzzle to untangle, but a gentle reminder that beneath the apparent complexity of the world lies a deep simplicity, a structure so elegant that it allows atoms to cluster, stars to ignite, minds to form, and dreams to rise. A structure that allows this moment to exist exactly as it does. The universe does not rush, it does not force, it does not hurry, it unfolds, one informational distinction at a time, one quantum event at a time, one gentle update after another, a tranquil sequence woven into the fabric of existence. And as you rest within that fabric, you are invited to drift on the soft currents of cosmic information, allowing your thoughts to dissolve, allowing your body to grow still, allowing your awareness to float in the quiet space between understanding and sleep, held by the universe, held by its code, held by the patterns that shape all things, until the boundaries of thought grow faint, and the quiet question beneath everything settles into a calm, restful hum, a hum made of information and wonder, and the soft unfolding of reality itself. Information moves through the universe in ways so quiet, so subtle, that most of its presence goes unnoticed, yet it is always there, shaping the world with a precision deeper than matter, deeper than energy, deeper than anything we can touch. You are surrounded by information, immersed in it, woven from it. Even now, as your thoughts soften and the edges of awareness blur into a calm, drifting state, information continues its work, ordering, distinguishing, shaping, not loudly, not dramatically, but with the soft persistence of natural law. One of the most transformative ideas in modern science began not in physics, but in communication, in the study of how messages travel across noisy channels. Claude Shannon's information theory showed that information is not meaning, not emotion, not interpretation, but structure, distinction, the ability to tell one possibility from another. A bit, in Shannon's terms, is the simplest possible choice between two alternatives, 1 or 0, yes or no, presence or absence. This small building block became the foundation of digital communication, computation, and in time, a new way of thinking about the universe itself. Because if information can be treated as physical, if it can be measured, counted, stored, and erased, then it begins to resemble something that belongs not only to messages and machines, but to the world at its most basic levels. As you drift deeper into this idea, you may begin to feel how gentle its implications are. Information becomes a soft undercurrent beneath the behavior of particles, beneath the unfolding of physical processes, beneath the structure of reality. When scientists discovered that erasing information has a physical cost, that even the smallest deletion produces heat, they realized something subtle but profound. Information is never free. Landauer's principle tells us that the act of forgetting requires energy, that information is tied to the physical world in a way that cannot be separated. This principle is delicate, almost whisper-like, yet its implications ripple through physics in every direction. If information has energy cost, then information must be real as the mass of a particle, as real as the vibration of an atom, as real as the gentle flow of time carrying you through this moment. And so the universe begins to look less like a place where things simply exist, and more like a process where things encode, store, and exchange information. Particles collide, and in doing so, they update one another's states, as if sharing quiet messages about their properties. Fields fluctuate, not randomly, but according to rules that preserve information in subtle ways. Even empty space is not truly empty. It holds quantum fluctuations that contain information about what could be, what might occur, what possibilities exist within the fabric of reality. The universe becomes a tapestry of distinctions, a vast system constantly recording its own evolution, each moment folded gently into the next. Physicist John Wheeler captured this shift with a phrase that echoes like a soft mantra through modern theoretical physics. It from bit. The idea that every it, every particle, every field, every structure, every galaxy arises from a fundamental bit, a unit of information, a yes or no distinction, a quantum choice encoded in the universe itself. Wheeler did not mean that reality is a computer program or a digital simulation, but that information may be the bedrock from which all physical quantities emerge. Matter, energy, space, time, all might be secondary, not primary ingredients, but consequences of underlying informational processes. As you rest deeper into this thought, you might feel its quiet elegance. Information is simple. but from simplicity comes everything. A binary distinction at the smallest scale can unfold into a universe of intricate structures. Just as a branching fractal grows from a simple rule and a snowflake from a basic molecular pattern, so too might reality grow from informational choices made at unimaginable small scales with unimaginable consistency. The universe seems continuous to us only because our senses are tuned to large scales, the scale of flowing rivers, rising hills, drifting clouds, and familiar objects. But beneath these smooth surfaces lies the discreteness of atoms, the digital clarity of quanta, the binary outcomes of measurements. Each tiny piece of matter contains its own information about state, momentum, spin, position, information that determines how it will behave, how it will interact, how it will influence the unfolding of the world around it. You do not feel these distinctions directly. Just as you do not feel the individual pixels of an image when viewed from far away, yet the image exists because of them. Reality exists because of them. This perspective does not diminish the universe, does not reduce its beauty. Instead, it reveals a deeper harmony, a calm logic beneath the apparent complexity of nature. If the universe were only matter, inert, solid, continuous, its behavior would be rigid, unchangeable, unintelligent. But a universe built on information is a universe capable of adapting, evolving, responding, storing history in the structure of its fields, remembering interactions in the states of its particles, a universe that is dynamic not just in appearance but in essence. This brings a sense of serenity, a knowledge that the laws of nature are not arbitrary but arise from the gentle logic of information itself. A logic that regulates entropy, that guides thermodynamics, that shapes quantum phenomena, a logic that underlies the flow of heat, the direction of time, the behavior of light, all governed by the preservation and transformation of information. As your mind softens, as your awareness drifts in and out of conceptual focus, you may notice that information theory has a way of creating calm. It suggests a universe that is comprehensible, a universe that follows rules, a universe that speaks in patterns that can be understood. Not completely, not all at once, but slowly, patiently, in small, discrete steps, just as information itself is handled in small, discrete units. This gentle correspondence between the structure of thought and the structure of reality creates a softness, a feeling that the universe is not chaotic, not senseless, but patterned, ordered, detailed in a way that invites exploration and rest in equal measure. Binary systems, those simple yes or no foundations of computation, mirror something remarkably similar in the quantum world. Not perfectly, not literally, but analogously. Quantum events collapse into discrete outcomes. A particle is here or there, its spin is up or down, its energy level rises or falls. Distinct, finite, digital-like. Physicists call these outcomes eigenstates, definite results chosen from a field of possibilities. Each choice represents new information written into the world, a quiet update in the ongoing computation of reality. To imagine this is not to imagine machinery, but to imagine clarity, the clarity of a universe that makes tiny decisions billions of times per second, across billions of particles, each decision shaping the next moment, in an endless sequence of informational transitions. And somehow, from these transitions, beauty arises. This beauty can be seen everywhere. In the structure of a snowflake, where temperature, humidity, and molecular geometry combine into crystalline patterns with such delicate logic that no two are ever alike. In the architecture of crystal lattices, where atoms align in precise repeating arrangements, their structure dictated by the informational rules of chemical bonding and spatial minimization. In the genetic code of life, where sequences of base pairs store, transmit, and express information that guides the development of organisms, from the simplest bacteria to complex, conscious beings, all of it emerging from encoded distinctions, adenine or thymine, guanine or cytosine, a biological binary woven into the chemistry of life. These examples carry a kind of calm clarity. They tell us that information is not something foreign to nature. It is nature. It is the logic that lets complexity grow, that lets order emerge, that lets the universe evolve into stars, planets, oceans, forests, and quiet moments like this one. A universe built from information is not abstract, not distant, not mechanical. It is intimate. It is intricately textured. It is quietly alive with structure. As you drift deeper into rest, You may notice how natural it feels to imagine reality as a sequence of informational states, like pages of a book flipping softly, each one carrying the story forward, each one containing the encoded details that shape the next. Yet the story is not linear or bound by narrative. It is spacious, expanded, woven in every direction, spreading outward like ripples on a calm lake, each ripple representing information flowing through the universe, subtle, precise, inevitable. And in this spaciousness, there is room for rest, room for thoughts to dissolve, room for awareness to float gently towards sleep, without pressure, without urgency, without expectation, guided softly by the understanding that the universe itself moves slowly in informational steps, measured, discreet, calm, and that you, in this moment, are part of that calm. At first glance, space feels smooth. You imagine distances stretching out as continuous lines from here to the moon, from the moon to the sun, from the sun to the distant stars, a soft fabric, without edges, without pixels, just a quiet expanse. Time, too, seems to flow, like a river that never breaks, moving from one moment to the next without interruption, without gaps, an unbroken stream. But when physics looks more closely, when it peers into the very smallest scales that reality allows, the picture begins to change. The smoothness starts to dissolve, and what appears beneath it is something more granular, more discrete, more quietly digital. In theoretical physics, there is a scale so small that it sits at the edge of what our current laws can meaningfully describe. This is the Planck length, roughly 1.610⁻35, 1.610⁻35 meters. It is not just a tiny distance, it is unimaginably tiny, smaller than an atom by a factor so enormous that the mind can't really hold it. And yet, it is here that many physicists suspect space might stop being smooth and start being fundamentally discrete. Alongside it sits the Planck time, about 5.410 45.410 44 seconds, the time it would take light to travel one Planck length in a vacuum. The smallest meaningful tick of duration that our current theories can even talk about coherently. Below these scales, our equations lose their certainty. Our models break down, and the idea of distance and time as continuous quantities begins to blur. The suggestion, soft but profound, is that there may be no smaller in any physically meaningful sense, that reality, at its deepest level, does not divide forever, that space and time themselves could be pixelated. To imagine pixelation, you might think of a digital screen. From far away, the image looks smooth, a gradient of colors, a soft curve, a clear shape. But as you move closer, the illusion of continuity begins to fall apart. You start to see tiny squares, individual pixels, each one a distinct unit, no half pixels, no continuous film of color, just discrete blocks arranged with such density that your mind blends them into a flowing image. Physics suggests something similar might be happening with space. At human scales, at planetary scales, even at atomic scales, space feels continuous, measurable to arbitrary precision. But if the Planck length marks a fundamental minimum, then there may be no in-between two neighboring points at that scale, no smaller step, no finer subdivision. The universe would have a smallest spatial increment, a pixel size for reality. Time may behave similarly. We often speak as though time were a real number line, where every moment has another closer moment just before it, and another just after, and so on, forever, down to infinitely small fractions. But if the Planck time marks a fundamental unit, then the flow of time may actually be a sequence of steps, tiny ticks, each one corresponding to an update in the state of the universe, too fast to perceive, too fine to feel, yet discrete in principle. From this vantage point, reality stops looking like a continuous movie reel and starts to resemble individual frames, not in a literal cinematic sense, but in a deeper physical way. Each frame a complete configuration of all fields and particles, each tick of time taking the universe from one configuration to the next. Underneath these pictures sit the quantum fields. In modern physics, particles are not tiny marbles moving through empty space. Instead, there are fields spread out through space, permeating everything. An electron field, a photon field, a quark field, and particles are excitations of these fields, like ripples or quanta of vibration. These ripples are not continuous in any arbitrary amount. They come in discrete packets, quanta. An electron field cannot carry half an electron in the way a classical wave could be cut smoothly. The field either has an excitation corresponding to an electron, or it does not. Energy levels in atoms are quantized as well. An electron bound to a nucleus can only occupy specific energy states. No energies in between, no continuous spectrum, just allowed levels, steps in a ladder. When an electron shifts from one energy level to another, it absorbs or emits a photon with exactly the right energy. No more, no less, a precise, discrete change. This is the quiet digital heartbeat of quantum fields. They update in jumps, in units, in quanta, not as smooth analog flows. At the deepest level, what we sense as continuity may be a large-scale illusion. The way a distant galaxy looks like a single smooth glow, even though it is made from billions of stars. The way a woven cloth feels like a single surface, even though it is composed of tiny interlaced threads. Space and time themselves may be woven, each thread a discrete unit. Planck-length fibers interlocked into the fabric of space-time. Quantum field threads vibrating and updating in tiny steps. The mathematics that describes these processes is inherently quantized. Differential equations give rise to discrete spectra. Operators have discrete eigenvalues, and these mathematical structures are reflected in experiment, in spectral lines of atoms, in the quantization of charge, in the discrete nature of particle interactions. Discretized mathematics does not appear because humans prefer integers. It appears because the universe answers certain questions with specific values, not a continuum of possibilities but a set of allowed outcomes. When physicists run simulations of quantum fields, they often place them on a lattice, a grid that represents space broken into small units. Each point on the lattice carries information about the field's value there, and time is advanced in discrete steps. The configuration of the field updated according to the rules of the theory. This is not necessarily how reality is structured. It is a computational tool. But the fact that our best approximations use discrete steps and finite grids resonates with the idea that space-time itself might be fundamentally granular. The simulation analogy can be misleading if taken literally, but it offers a helpful image. Reality evolving frame by frame, each frame consistent with the laws of physics, each update propagating information from one moment to the next, smooth at a distance, but stepwise underneath. To hold this picture gently, without turning it into science fiction, you can imagine starlight crossing space. From here on Earth, a star's light seems like a continuous beam, a soft stream of illumination reaching your eyes from many light years away. Yet at the quantum level, that light is not a flow of continuous energy. It is a sequence of photons. Each photon a discrete packet of energy, a single quantum of the electromagnetic field, arriving one by one, or in small groups, even if your senses blend them together into a smooth glow. The night sky you see is built from countable events, photons arriving, being absorbed, transferring information from remote stars to the molecules in your retina. Like pixels in a cosmic image, they combine to form what appears continuous, but each pixel is distinct. You can also think of a digital screen in the dark. From a distance, you see a tranquil scene, a nebula, a galaxy, a field of stars, gradients of color and brightness flowing across the display. Move closer, and the illusion breaks. You see a grid of tiny dots, each dot holding a specific value, a defined color, a defined intensity, updated over time by discrete changes in their state. The beauty of the scene is not lost because of the pixels, it exists because of them. The scene is only possible because there is a finite countable structure underneath the image. In the same way, the universe may be beautiful precisely because it is built from tiny units, finite bits of space, time, and field excitations woven into a coherent whole. Imagine a piece of cloth under your fingertips. It feels smooth, continuous, but if you look closer, you see threads. Look closer still, and you see fibers, and further still, molecular patterns. At each deeper level, the apparent continuity resolves into a structured discreteness, a regularity, a repeated pattern, each level enabling the strength, the flexibility, the gentle surface you experience. Space-time may be like that cloth. At cosmological scales, it curves gently around massive objects. At human scales, it feels flat, ordinary. At microscopic scales, quantum fluctuations begin to ripple, and at Planck scales, perhaps space-time is thread-like or latticed, or combinatorial, a network of discrete units from which the larger smoothness emerges. The mathematics of quantum gravity and lattice models often leans toward this kind of structure. Graphs, simplices, discrete approximations, and while these are still speculative, they share a quiet, unifying insight. Continuity can arise from the collective behavior of many small, discrete elements. When we say that discretized mathematics underlies modern physics, we mean that the universe often responds in quantized steps rather than smooth slides. Atomic spectra contain lines, not continuous bands, each line corresponding to a specific energy transition, a discrete change in the state of an electron. Charges come in multiples of a fundamental unit, never in arbitrary fractions. Spin has quantized values. Angular momentum in quantum systems comes in discrete packets. Even the vacuum has quantized modes. Standing waves of fields in constrained spaces, their frequencies following discrete patterns determined by boundary conditions. These are not artifacts of measurement. They are signatures of a universe that prefers certain values, a universe whose behavior at small scales is governed by definite steps. In your mind's eye, you might now combine these insights, Planck scales hinting at minimal units of space and time, quantum fields updating in discrete quanta, light and matter exchanging energy in packets, mathematics returning discrete spectra again and again. Slowly, a picture forms of a universe that is not continuous in an absolute sense, but finely grained, made of tiny units, so many and so small that to you they appear as a smooth whole. The way a tranquil pond looks like a single surface, even though beneath it countless molecules are moving in discrete interactions. The way a soft tone sounds continuous, even though it may be generated by individual vibrations, each cycle a separate oscillation. Holding this picture can be strangely calming. It suggests that reality has a concrete foundation, that there is a smallest scale beyond which questions about smaller may lose their meaning. It suggests that instead of an infinite regress of ever smaller divisions, there may be a bottom layer, a finite grain, on which everything else rests. The universe becomes less like an endlessly divisible fog, and more like a finely woven fabric, with threads you can, in principle, count, even if you never will. Threads that obey rules, threads that give rise to all the patterns above. This discreteness, this pixelation, does not make reality harsh, it makes it precise. It makes it possible for information to be stored, for events to be distinct, for histories to be defined, for the universe to compute its own evolution step by step. As your awareness grows softer, as thoughts pass like faint clouds across an evening sky, you are free to let these details blur. To let the idea settle not as a sharp diagram, but as a gentle impression, that beneath the smoothness of your experience, beneath the flowing sense of time, beneath the seamlessness of space, there may be an underlying grain, tiny units, tiny ticks, through which the universe quietly updates itself. Frame by frame, state by state, quantum by quantum, a pixelated reality, woven so finely that to your resting mind, it feels like one continuous, tranquil, unbroken whole. There is a quiet idea woven through modern physics, an idea that rarely announces itself loudly, but reveals its presence in small ways through equations, through patterns, through the underlying behavior of matter. It is the idea that the universe behaves as though it is performing a computation. Not a literal computation in the sense of circuitry or code, not a program written in lines of text, but a natural computation, a process where information is transformed, updated, propagated, and where the laws of physics are the rules that govern how those transformations occur. When you let this idea settle softly, without urgency, without the noise of metaphor, you begin to see how deeply intertwined computation and physics become. Even in this moment, as your awareness drifts gently, the universe is updating itself, state by state, through interactions that follow precise rules. The behavior of particles, the evolution of fields, the spreading of light, the cooling of matter, all can be described as informational processes, unfolding according to fundamental operations. The physical limits of computation give the first quiet hint. In classical computers, there is a maximum speed at which information can be processed, limited by how fast signals can travel, how much energy each operation costs, and how much heat must be dissipated. These limits arise not from engineering shortcomings, but from the laws of physics themselves. Light speed sets an upper bound on how fast information can move. Thermodynamic laws set bounds on how efficiently information can be erased. Quantum mechanics sets bounds on how much information can be stored in a given energy scale. And when physicists examine these limits, they notice something interesting. They match the behavior of the physical world itself. It is as if the universe is already operating at the ultimate edge of what is computationally possible, using energy in the smallest packets, processing information in discrete steps, storing states in quantum degrees of freedom, and never violating the minimal costs imposed by thermodynamics or relativity. The universe behaves like the most efficient computer imaginable, not because it is one in any artificial sense, but because the laws of physics govern computation at the deepest level. To imagine the universe as a grand calculation is not to see it as mechanical. It is to notice that every physical process is an update rule, that each moment follows from the previous one through the application of deterministic laws, probabilistic laws, or quantum amplitudes flowing across fields. A photon moves not by chance, but by following the equations of electromagnetism. A particle interacts not arbitrarily, but through the quiet symmetry of quantum fields. A wave function evolves according to the Schrödinger equation. Every rule is an instruction. Every outcome is the result of applying that instruction. And when instructions govern transitions between states, that is computation. Not in silicon, but in space-time itself. To hold this gently, you can imagine a simple cellular automaton, a grid divided into cells, each cell able to occupy a finite set of states, and each state at the next step determined by simple rules, rules applied repeatedly, locally, patiently, until patterns emerge. One of the most famous is Conway's game of life. Simple beyond belief, yet capable of generating structures that move, replicate, interact, and behave almost lifelike. All from rules that could be written on a small scrap of paper, apply a few conditions, turn black squares on or off, repeat, and watch complexity blossom. The universe feels nothing like a flat grid, nothing like a toy model, and yet the analogy is calming. It shows that astonishing complexity can emerge from very simple rules, that intricate behavior does not require an intricate recipe, just a consistent one. Patterns that look alive can arise naturally. Structures that self-organize can appear spontaneously. This principle, emergence from simple rules, is found throughout physics. Quantum electrodynamics, general relativity, condensed matter systems, even the formation of stars all follow basic mathematical principles, yet yield incredibly intricate phenomena. It invites the thought that the universe could be evolving through fundamental operations, tiny transformations executed again and again, each one producing the next moment in time. The fabric of space can be imagined as carrying information too, not as a physical grid of points or nodes, but as a field with values that can change, that carry curvature, that store energy, and that interact with the matter within them. General relativity describes gravity not as a force, but as curvature determining how matter moves, and matter determining how curvature forms. This relationship behaves like a computation, a feedback loop where information flows between matter and geometry, updating the configuration of space-time from one moment to the next. Even the vacuum seems to compute, virtual particles emerging, interacting, vanishing, their transient states allowed and constrained by the informational rules of quantum field theory. Nothing moves without exchanging information. Nothing interacts without updating states. Nothing persists without storing some trace of what it has been. When thinkers like Seth Lloyd describe the universe as a quantum computer, the idea is not literal. It is an observation that the transformations governing matter and energy mirror the same transformations that define computation. A quantum system carries information in qubits. Superposition allows many possibilities to coexist. Entanglement carries correlations across space, and quantum operations transform states in well-defined ways. The universe contains these operations everywhere, in atomic transitions, in particle interactions, in the evolution of wave functions, and with each transition, each update, each propagation, information moves. This movement is computation, not designed, not engineered, but the natural way the universe evolves. When viewed like this, with calm, with patience, with scientific clarity, even the largest structures in the cosmos begin to resemble the outcomes of simple, accumulating rules. Galaxies form from small ripples in the early universe. These ripples emerge from quantum fluctuations. Those fluctuations arise from field dynamics, and the field dynamics follow equations that can be interpreted as update rules. Small differences amplify over time, just as in cellular automata. Patterns branch, collide, stabilize until the universe acquires its large-scale structure, filaments of galaxies, vast cosmic voids, clusters bound by gravity. An intricate pattern arising from fundamental principles. The elegance lies in the contrast, the simplicity of the rules, the complexity of the result. A quiet reminder that the universe does not need complicated machinery, only consistency, intentional laws, and time for structure to bloom. If you listen closely to this idea in the stillness of thought, you may feel how gently it reshapes the image of reality. The world becomes a system continuously transforming itself. State by state, moment by moment, each moment containing the information required to produce the next. There is no rush, no haste, no violence in this transformation, only a paced unfolding, like a fractal extending its boundary, or a wave moving through water, smooth at large scales, discrete in its underlying mechanics. The universe does not skip steps. It evolves in accordance with the rules it obeys, every interaction a computation, every propagation an operation, every moment a result. And as you drift, as your awareness grows light, you might sense the serenity in that structure. Everything is connected, not by threads of intention, but by threads of information, moving softly through space and time, carrying the logic of the universe forward, with the same quiet reliability that lets you breathe, lets you rest, lets you sink into a calm, drifting state, held by a world that is always unfolding, always computing. Always one moment flowing gently into the next. At the quiet heart of modern physics, beneath the layers of matter, beneath the ripples of fields, beneath the structure of space itself, there is something even more subtle, something that behaves like a language woven into the fabric of reality, a language spoken not with words or symbols, but with correlations, with quantum states, with delicate patterns of possibility. This is the domain of quantum information, and when you step into it gently, without haste, without the need to grasp everything at once, you begin to sense how the universe communicates with itself, how it stores its history, how it preserves its structure, and how it weaves together moments and places in ways that feel almost dreamlike. In this quantum world, the basic unit of information is not a bit, but a qubit. A qubit is strange, not because it is mystical, but because it behaves in a way that classical logic never imagined. A classical bit is either 0 or 1. A qubit can be in a state that is partly 0 and partly 1, not alternating between them, but occupying both potentialities in a soft overlap, a superposition of possibilities. This superposition is not vague, not undefined, it is precise, mathematically exact, a defined quantum state that holds more structure than any classical bit could. And as you drift slowly through this idea, you might feel the softness of it. A state that is not yet decided, not yet measured, still open, like a thought that has not yet settled, a possibility not yet collapsed into a single outcome. Quantum information is not carried by the qubit alone. It is carried by the relationships between qubits. This is where entanglement arises, a phenomenon in which two or more quantum systems become correlated so deeply that their states cannot be described independently, even if separated by great distances. If one qubit is measured, the outcome determines the structure of the other, not because information travels from one to the other, but because the information was never stored separately to begin with. The universe treats them as parts of a single, unified state, a single object spread across space. It is a quiet reminder that distance is not always a barrier at the deepest levels of reality, and that information can exist in patterns that stretch beyond the intuitions of classical thought. To imagine entanglement gently is to imagine threads of connection woven through space, not physical strings, but informational links, delicate, invisible, and precise, linking particles in a way that defies our ordinary sense of separation. Quantum information flows softly through processes that seem almost impossible, like quantum teleportation. Teleportation does not move matter. It moves the information that defines the quantum state of a system. Using entanglement and a careful sequence of operations, a quantum state from one particle can be transferred to another, without the state itself traveling through the space between. What moves is the structure, the correlations, the informational essence of the state. This tells us something subtle and quietly profound. The universe treats information as something fundamental, something that can be moved, preserved, reconstructed, without copying, without violating the constraints of quantum mechanics, without losing the integrity of the state. Information becomes a conserved quantity, as essential as energy or momentum, a thing the universe protects. The idea of conservation reaches one of its deepest expressions in the physics of black holes. For many years, physicists believed that anything falling into a black hole lost its information forever, that the details of matter absorbed by the event horizon would vanish, leaving behind nothing but mass, charge, and spin. This created a tension, because if information could be destroyed, the laws of quantum mechanics would be broken, and the universe would lose its fundamental consistency. But growing evidence from thought experiments, from holographic dualities, from the mathematics of entropy and symmetry, suggests that the universe does not allow information to be lost, even in the depths of a black hole. The surface area of the event horizon reflects the amount of information the black hole contains, not its volume. A two-dimensional boundary holding the data of a three-dimensional interior, a hint that reality might encode itself in ways more intricate than our usual intuitions imagine. This idea, softly unfolding, leads deeper into the holographic principle, but without moving ahead, we can linger here, in the gentle recognition that black holes act like custodians of information, absorbing matter, but preserving the structure in encoded form, letting the universe remain coherent, consistent, intact. When physicists explore these quantum informational ideas, they begin to see that information shapes physical behavior as strongly as forces or fields. A particle's spin is information, a quantum number stored in its state. A photon's polarization is information. A wave function is a vast reservoir of encoded possibilities, and when it evolves, when it interferes, when it collapses, the information flows and changes, constrained but conserved. Even the vacuum, the quiet background beneath all fields, contains information. Virtual excitations, symmetry structures, correlation patterns, a resting sea that is never truly still. Thinking of the world as an informational river is not poetic exaggeration. It is scientific precision. Information flows from one moment to the next, not like water but like correlations, hidden, structured, consistent. Whenever two particles interact, they exchange information about their properties, their momenta, their phases, and those exchanges shape future behavior. Whenever a quantum state evolves, its changes reflect the rules for how information propagates. Whenever light travels, it carries the structure of what produced it, photons ferrying information across great cosmic distances, arriving at your eyes as silent messengers of ancient events. Even decoherence, the process that suppresses quantum superpositions in the macroscopic world, is an exchange of information with the environment, a spreading of correlations so complete that the system can no longer maintain its fragile quantum state. Information determines what remains quantum and what becomes classical. It determines what is possible and what is forbidden. It determines how particles behave, how matter forms, how the universe maintains coherence from one moment to the next. As thoughts soften, as awareness drifts toward the gentle border between waking and sleep, you can imagine the universe as a vast network of informational relationships, each particle holding a small piece of a larger pattern, each interaction reshaping that pattern, each moment updating the configuration of correlated states, all of it unfolding according to simple rules, yet giving rise to structures of immense beauty. The connections stretch across space, linking distant regions. They stretch across time, carrying the history of previous states. They stretch across scales, from the smallest quanta to the largest galaxies, all bound together by the language of quantum information. Not a language spoken aloud, but a language written in the mathematics of reality, precise, abstract, beautiful, and quietly unfolding in every corner of existence. And as you gently drift, you can rest in the thought that this informational substrate is always present, steady, reliable, a structure beneath all motion, a logic beneath all change, a calm foundation beneath the universe's ever-shifting surface. In the soft ebb of your thoughts, you can feel how this informational fabric supports everything, how it holds the stars, the particles, the fields, and even the thoughts that move slowly through your resting mind. Each one a pattern, each one a configuration, each one a small ripple in the quiet river of information that shapes reality, moment by moment, breath by breath, state by state, gently, precisely, eternally. There is a quiet idea in theoretical physics, one that feels almost like a whisper behind the structure of reality, an idea suggesting that the world we move through may contain far less volume of information than it appears, that the essence of a region of space, the total amount of information it can hold, might be encoded not within its interior, but along its boundary. This is the seed of the holographic principle, a principle so gentle, yet so far-reaching, that when you let it settle into your thoughts, it feels as though the universe is revealing one of its most intimate secrets. The concept begins with a simple observation. When you increase the size of a region of space, you might expect that the total information it contains would grow with its volume, more space, more room for data, more capacity for information. But black holes suggest something different. Their entropy, a measure of how many microscopic configurations the black hole can have, does not scale with the volume inside. It scales with the area of the event horizon. A black hole twice as wide can hold 4 times the information, not 8. This shift from volume to area is not merely a mathematical curiosity. It is a sign that the universe may store information on surfaces, that the boundaries of regions may hold the key to what lies within. Imagine a sphere. Intuitively, we think its information would be spread throughout its interior, like grains of sand within a hollow shell. But the holographic principle says otherwise. The true informational content is proportional to the surface area, as if reality projects inward from the boundary, as if the deepest interior is a kind of elaboration generated by information inscribed on the edges. This idea emerged slowly from the study of black hole thermodynamics, but it grew into a broader framework when physicists realized it applies not only to black holes, but to space itself. In certain theories, especially those involving curved space-time and quantum fields, it is possible to describe the physics inside a region using only the information on its boundary. This correspondence between interior volume and boundary data is not just symbolic, it is mathematically exact in some formulations. It suggests that the world you move through, the three-dimensional reality you experience, may arise from deeper information encoded elsewhere, not above or below, not outside or inside, but on surfaces woven into the fundamental structure of space-time. To imagine it gently, you can think of a hologram. A hologram is a two-dimensional sheet, flat, thin, yet when illuminated with the right light, it produces a vivid three-dimensional image, an image with depth, with perspective, with structure. The sheet itself does not resemble the image it encodes. Its patterns are strange, interference fringes, waves of brightness and darkness, and yet all the information needed to reconstruct the three-dimensional object is stored on that flat surface. The holographic principle is far deeper and far more subtle than any physical hologram. But the metaphor carries the essence. A lower dimensional surface can store the full informational content of a higher dimensional region. Reality may be organized similarly, not as a projection in any visual sense, but as an informational structure where boundaries hold more significance than intuition suggests. As you breathe softly, as your thoughts drift outward, you may feel the calmness in this idea. It does not say that reality is an illusion. It says that reality is efficient, that the universe uses the minimal amount of information required to encode its structure, folding data onto boundaries, letting the interior unfold through the logic of quantum correlations. This efficiency is not mechanical, it is natural, emerging organically from the mathematical rules that govern fields, space-time, and the flow of information. At the heart of the holographic idea is the preservation of information, the principle that information cannot be created or destroyed, only transformed. This is why the apparent loss of information in black holes was once so troubling, because it threatened the consistency of quantum mechanics, which requires that information always persists in some form. And now, after decades of insight, most physicists believe that black holes do preserve information, not in their interiors, but in delicate correlations spread across their horizons, encoded in the fine structure of the event boundary. This means that information is one of the most protected quantities in the universe, a constant thread woven through all processes, never severed, never annihilated, only woven into new patterns. These patterns often resemble threads, not physical fibers, but lines of correlation connecting places and moments. Threads of entanglement stretching silently through space, binding particles into unified quantum states. Threads of interaction carrying information from one moment to the next. Threads of structure woven through fields, and threads of geometry encoded on boundaries, giving rise to the shape of spacetime itself. If you imagine these threads softly, they do not appear as lines or chords, but as gentle relationships, subtle agreements between quantum states, a kind of cosmic harmony expressed through mathematical correlations, so quiet that they never disturb the world you sense, yet so powerful that they determine the architecture of reality. When physicists say that information shapes physics as much as mass or energy, they mean that the behavior of the universe depends fundamentally on how information is arranged, which correlations exist, which entanglements persist, which boundaries encode the structure of the whole. Mass curves spacetime, but information determines how fields behave within that curved geometry. Energy moves matter, but information determines how matter evolves from moment to moment. Force determines trajectories, but information determines what states are possible, which configurations are allowed, which paths can be taken. The universe is not made of information alone, but information is the guide, the quiet director that tells matter and energy how to behave, the underlying logic that keeps the laws of physics consistent, elegant, and coherent. If you allow these ideas to drift softly through your mind, not demanding clarity, not insisting on precision, you may feel how quantum information gives the universe a sense of continuity, even when its processes are discrete, a sense of coherence, even when its states are uncertain, a sense of unity, even when its components appear separated. The threads of connection run silently, binding distant stars in shared quantum origins, linking particles in correlations that outlast separation, carrying information across light years, through photons that have traveled since the early days of galaxies, each one a messenger of ancient events. These connections shape everything: the glow of nebula, the stability of matter, the emergence of atoms, the structure of molecules, and even the thoughts assembling quietly in your resting mind. Each thought a pattern of neural activity, each neural activity a flow of electrical information, all of it woven seamlessly into the deeper informational fabric of reality. In the softness of this moment, you can rest knowing that the universe is held together not by mystery, but by correlation, not by chaos, but by structure, not by uncertainty, but by the rules governing how information behaves. Quantum information does not need to be grasped fully to be felt. Its presence is everywhere, in the stability of atoms, in the behavior of light, in the geometry of space, in the persistence of memory, and in the gentle unfolding of the world around you, quiet, intricate, connected, like a dream woven from threads of meaning and structure. A dream in which the universe carries its own language, the language of information, flowing softly, eternally, through everything. There is a quiet thought that sits at the edge of modern physics, a thought so soft, so delicate, that it feels almost like a shimmer in the background of reality. The thought that the world you move through may not be built in the way your senses believe, that depth, volume, distance, and three-dimensional structure might be expressions of something deeper, something woven into the boundaries of space. To let this idea unfold gently, you can begin with something familiar: a hologram. A hologram is a thin surface, flat, unassuming, and yet, when illuminated with the right kind of light, it produces an image with depth, an image that seems to extend backward into space, even though all the information needed to create it is stored on a two-dimensional sheet. The hologram does not imitate depth, it encodes it, using interference patterns far more intricate than ordinary pictures, patterns that capture how waves combine, how light interacts, how the full three-dimensional scene can be reconstructed from the surface itself. It is a reminder that appearances can be deceiving, that the true structure may lie elsewhere, that surfaces can carry far more information than they seem. In theoretical physics, this idea becomes something far more profound, a principle that suggests the entire universe might operate this way. That the three-dimensional world is a kind of emergent structure arising from information encoded on distant boundaries, not literally projected, not imposed, but arising through the quiet mathematics of quantum fields and gravitational theory. This is the essence of holography, the recognition that the deepest description of a region of space may be written in fewer dimensions than the region itself. It is not a metaphor, not an analogy, but a mathematical insight with surprising precision, a soft, intricate relationship between geometry and quantum information. One of the clearest examples comes from a remarkable correspondence discovered in theoretical physics, a relationship between two very different descriptions of the same reality. On one side, there is a universe with gravity, a curved space-time in which matter moves, where distances stretch and surfaces curve, a universe with depth. On the other side, there is a universe without gravity, a quantum field theory living on the boundary, flat, lower dimensional, yet containing all the information needed to reconstruct the higher dimensional world. This correspondence was formalized in the work of Juan Maldacena, a discovery that showed how a world with gravity could be fully described by a theory on its boundary without gravity at all. Two very different languages, two very different pictures, and yet they described the same universe. It was as if a three-dimensional story had been rewritten on a two-dimensional surface, without losing a single detail. To drift into this idea gently, you can imagine a vast cosmic sphere, not in the literal sky, but in conceptual space. Inside the sphere are galaxies, fields, particles, waves, all moving and interacting, all forming a living, breathing structure of space and time. Now imagine that the total information of everything inside, every particle, every fluctuation, every curve of geometry, is encoded on the surface of the sphere, stored as correlations, as patterns, as an intricate map of quantum information. Inside the sphere is the world you see, but the information that defines it resides on the boundary, not projected physically, but present in the deeper mathematics that link surfaces with volumes. The universe does not become smaller under this view. It becomes more elegant, a place where boundaries and interiors are joined by quiet informational laws, a place where the structure of space can emerge from patterns of entanglement living on its edges. Black holes provide the clearest hint of this relationship. A black hole is a region where gravity has become so strong, so dominant, so absolute, that nothing inside can escape, not even light. Yet the information about what falls in, the total number of microscopic configurations, is not stored in the interior. It is stored on the event horizon, a surface with no thickness, a boundary between the world and the unobservable. The entropy of a black hole is proportional to the area of this boundary, a clue that information lives on surfaces, that nature counts area, not volume. The event horizon acts almost like a cosmic memory, recording the informational content of everything that enters, holding it in a delicate pattern, a pattern that does not vanish, a pattern that reflects one of the deepest laws of quantum theory, that information must never be lost. When physicists study the mathematics of these ideas, they find that space-time itself behaves like an emergent structure, a geometry that arises naturally from quantum entanglement patterns, as if the distances between points, the curvature of space, even the presence of gravity, were consequences of how information is arranged, not fundamental ingredients but outcomes, not raw ingredients but emergent properties. Imagine entanglement as the stitching thread of the universe, binding regions together. The more entangled two regions are, the closer they appear in space-time, the less entangled they become, the further apart they drift. In this view, distance is not a basic part of reality. It is a reflection of informational structure, a measure of how quantum states intertwine. Space-time is not the stage, it is the tapestry woven from correlations, from connections, from the gentle structure of quantum information. This brings us to a soft, cosmic metaphor. Reality may be like a vast, shimmering tapestry, a tapestry whose visible patterns are the three-dimensional world, mountains, stars, oceans, galaxies, but whose threads are woven on a deeper surface, a boundary where information is encoded, a boundary that determines how the interior structure unfolds. Each thread is a correlation, each crossing an entanglement, each pattern a region of space, woven together into the seamless whole you experience. The tapestry is not projected, not artificial, it is emergent, the natural consequence of how information organizes itself in a quantum universe. And the shimmering quality comes from the fact that these threads are not visible, not tangible, but mathematical, quiet, subtle, always shifting in response to the laws of physics, always reshaping the geometry of space, always giving rise to the form and flow of reality itself. To sit with this idea is to feel a gentle spaciousness, a soft expansion in your understanding, as though the world were opening inward, revealing the elegant logic behind its structure, a logic that does not shout, does not force, does not confine, but unfolds with the patience of a silent process, a process in which information and geometry are intertwined, where space is not a container, but a consequence, where gravity is not a force, but an expression of entanglement, where depth is not fundamental, but emergent, arising from the subtle interplay between boundaries and the patterns they encode. As you drift deeper into rest, you might imagine your awareness floating gently through this tapestry, not to analyze, not to solve, not to understand in a rigid sense, but simply to feel how delicate and beautiful the structure is, how the surface and the interior speak to each other, how information and geometry dance quietly, how reality emerges naturally from the harmony between them. You may feel a sense of calm, knowing that the universe is held together not by chance, but by structure, not by randomness, but by coherence, not by chaos, but by the quiet rules that govern how information organizes itself, rules so deep that they give rise to space, time, matter, and the gentle moment you are experiencing now, all woven into a shimmering whole, a holographic universe, quiet, precise, and endlessly beautiful. There is a quiet idea that has been gathering strength in modern physics, an idea that feels both ancient in its simplicity and futuristic in its implications. The idea that the universe may be built not from continuous substances or flowing fields alone, but from digital steps, from discrete updates, from tiny units that evolve according to rules as simple as they are profound. This idea is often called digital physics. Yet it does not claim that reality is engineered or artificial. It simply suggests that beneath the smoothness of the world you see, beneath the continuity of space and time, beneath the apparent fluidity of motion and change, there may exist a quiet scaffolding, a finite structure, a set of fundamental rules that gives rise to everything around you. To let this unfold gently, you can begin with the feeling that people have had for centuries, the feeling that the universe is governed by laws. These laws do not shout, they whisper, quiet relationships between quantities, between fields, between states, equations that act like instructions, telling the universe how to update itself from one moment to the next. If these instructions operate in discrete steps, if they proceed in increments so small that you never perceive them, then the world could be digital in its foundations, even though it appears smooth at the scales we know. Many physicists arrive at this thought from the belief that nature may be discrete rather than continuous. Discrete in the sense that there may exist a smallest unit of space, a smallest unit of time, a minimal pixel of reality. This does not make the universe rigid, it makes it precise. A discrete foundation avoids infinities, avoids paradoxes, avoids the issues that plague continuous systems at extremely small scales. When you combine quantum mechanics with gravity, the mathematics suggests that discreteness may be required, that space-time must have a granular texture, not visible, not detectable at large scales, but present as the underlying fabric. This idea brings calm clarity, a sense that the universe is not a boundless continuum waiting to be subdivided forever, but a finely woven cloth with a definite thread count, a finite substrate from which everything emerges. One of the most beautiful ways to imagine this discreteness is through cellular automata, simple computational systems that evolve according to local rules, rules specifying how each cell should update based on its neighbors. The rules can be incredibly simple, a few lines of logic, a handful of conditions, yet when these rules are applied repeatedly, step by step over many iterations, complexity blossoms. Patterns emerge, structures form, waves propagate, particles appear and interact within the grid. Some cellular automata even produce behavior that resembles the conservation of momentum, the persistence of particles, the collision of waves, emergent laws arising spontaneously from discrete rules. Stephen Wolfram has explored this possibility deeply, showing that incredibly simple rules can produce phenomena so intricate that they resemble the structure of physics itself. Not because the universe is a cellular automaton, but because both share a principle. Simple rules applied repeatedly can create complexity of astonishing depth. To imagine this gently, you might think of ripples forming in a pool of water. The ripples seem smooth, continuous, yet their shapes are determined by discrete interactions, molecules pushing neighboring molecules, tiny collisions propagating outward, each interaction simple, localized, but together creating flowing waves. In digital physics, the molecules are replaced by rules, and the waves become emergent structures, arising from the collective behavior of underlying units. This is not a metaphor, it is a pattern, a reminder that nature creates complexity from simple interactions, whether in fluids, fields, or fundamental rules. In the search for the universe's deepest foundation, physicists look for what they call update rules, rules that would determine how the state of reality evolves from one moment to the next, not in classical terms, but in a deeper, quantum-consistent way. These rules would govern the behavior of space-time, the behavior of particles, the behavior of fields, all at once. The search is not for equations written in human language, but for principles that nature already follows, principles encoded in its behavior. Some approaches see space-time as a network of discrete connections, nodes and links that update together, forming a dynamic graph whose structure determines geometry. Other approaches treat particles as excitations of underlying automata, appearing when certain rules converge, disappearing when those rules cancel. Still others approach spacetime as a computational process, a sequence of informational updates, with gravity emerging from entanglement and geometry emerging from correlation patterns. All these ideas share the belief that reality is not arbitrary, it is consistent, and consistency is often simplest when built from discrete rules. If these rules are simple, why does the universe appear continuous? Because simplicity applied repeatedly can create smoothness, in the same way that a digital image appears continuous when its pixels are small enough. The discrete nature of the underlying grid becomes invisible, not because it is absent, but because its scale is far below anything we can perceive. In this way, the universe may be digital without ever feeling digital, just as a woven fabric feels smooth, even though its threads are individually distinct. Continuity is an emergent illusion, the result of discrete steps woven together with immense density. The elegance of this perspective comes from the fact that minimal rules can produce maximal beauty. A few principles governing interactions might generate galaxies, atoms, fields, forces, all as emergent phenomena arising naturally from fundamental steps. This is the simplicity beneath complexity, the quiet order beneath chaos, the digital clarity beneath the analog world you perceive. Minimal rules do not limit the universe, they enable it. They give rise to structure, to symmetry, to geometry, to the long chain of interactions that form stars, organisms, consciousness, and the drifting thoughts that move quietly through your mind as you rest. There is a final idea woven softly through digital physics, the idea that the universe need not be a simulation to be computational, that a world built from discrete rules does not imply artificial origin, but natural emergence. A river is not a simulation because its flow obeys mathematical rules. A crystal is not engineered because it forms from atomic constraints, and the universe is not artificial because its behavior resembles computation. Natural systems compute, not by intention, not by design, but by following the laws that govern their structure. Atoms compute their states, fields compute their interactions, space computes its geometry, and the universe computes its next moment, automatically, inevitably, according to rules written in its foundations. This computation is not mechanical, it is organic, the natural unfolding of information under the laws of physics. It needs no external designer, because the rules themselves give rise to order, just as gravity gives rise to structure, and entanglement gives rise to spacetime. A computational universe is not artificial, it is elegant. It is self-consistent, self-sustaining, self-unfolding. A universe that evolves through discrete steps, quietly, patiently, moment by moment, rule by rule, processing the information that defines its state, and from those updates, creating the world you rest within. As your awareness softens, as your mind grows light, you may picture reality as a serene informational network, a web of tiny units, all interacting, all updating, all following the same simple principles, their collective dance giving rise to the beauty of the cosmos. A universe woven from tiny steps, emerging into flowing patterns, patterns emerging into galaxies, galaxies emerging into structure, structure emerging into life, and life emerging into consciousness, all connected by the quiet code of natural law, the digital heartbeat beneath the analog world, soft, subtle, eternal, guiding the universe through each moment and carrying you gently into the next. There is a quiet distinction that often gets blurred when people think about a digital universe, the difference between a world that is computational and a world that is simulated. One speaks of how nature behaves, the other of why it exists. One is about rules, the other about intention. And as you rest here, listening, drifting, you can let that difference spread out in your mind like a soft, unfolding pattern. A universe can be digital in its underlying structure, its space made from tiny units, its time advancing in discrete ticks, its fields updating in quanta, without being a simulation run by an external agent. A river follows equations, but it is not simulated water. A crystal grows according to precise atomic rules, but it is not a rendered image. In the same way, the universe may follow algorithmic laws, laws that map one state to the next, laws that process information with exquisite precision without being artificial. Digital does not mean fake. Algorithmic does not mean designed. It simply means that the unfolding of reality can be described as a sequence of operations, each operation transforming information, each transformation giving rise to the next moment. When you allow this thought to settle softly, it becomes clear that digital is a statement about structure, about the way events follow one another, about the grain of space-time, the quantization of fields, the patterns in which information flows. It is not a demand for an architect. The rules of nature might simply be not imposed, not chosen, just present. Like the properties of numbers, like the geometry of triangles, they are what they are, and the universe is what happens when those rules are allowed to express themselves. From these rules, from these algorithmic foundations, emergent complexity arises naturally. You can see this in simple systems. A short set of instructions governing how a pattern evolves, when repeated again and again, can produce structures that look surprising, intricate, almost intentional. In cellular automata, tiny digital worlds blossom with moving shapes, colliding patterns, self-replicating forms, all from rules you could summarize in a few lines. In nature, similar emergence occurs. Simple chemical interactions give rise to crystals, simple genetic instructions give rise to organisms. Simple gravitational attraction gives rise to galaxies, and the simple quantum rules governing fields and particles give rise to the entire structure of the physical world. Complexity does not require a complex recipe, only the repeated application of simple rules over time. The universe may be the ultimate example of this, an immense emergent structure arising from foundational laws that are themselves quiet, compact, and elegant. To imagine this gently, you might think of nature as an unfolding code. Not a code written in human symbols, but a code expressed in the language of physics, symmetries, interaction terms, conservation laws, boundary conditions, all combining to form the instructions for how reality evolves. This code is not compiled once, it is evaluated everywhere, always, in each interaction, each scattering event, each quantum fluctuation, every time a photon crosses a boundary, every time an atom absorbs energy, every time neurons in your brain fire quietly in the background of your resting thoughts. The code of nature runs in parallel throughout the universe. Not on hardware, but in reality itself, a living execution of the laws of physics. Recognizing this can bring a deep calmness. If nature is an unfolding code, then the patterns you see, stable orbits, chemical bonds, biological cycles, ecological networks, are not accidents. They are permitted outcomes of the laws beneath, expressions of the underlying rules. The apparent chaos of turbulent clouds or swirling galaxies or quantum fluctuations is not the absence of structure. It is structure at a level too intricate for the eye to track, a complexity derived from simplicity, an order that lies beyond immediate intuition, but remains anchored in firm mathematical ground. This realization allows you to rest inside a universe that is not arbitrary, a universe that is consistent, one in which every event is connected, not by fate, not by narrative, but by the logic of its deepest laws. In this light, what might feel like chaos becomes a kind of fine-grained order. Randomness in quantum events, fluctuations in fields, thermal noise, cosmic background radiation, all can be seen as features of the algorithm by which reality runs, necessary components of a process that generates diversity, explores possibilities, prevents the universe from collapsing into rigid repetition. Instead of fearing randomness, you can see it as part of the code, a controlled looseness that allows structure to evolve, a gentle unpredictability without which no new configurations could emerge. Order and chaos are no longer opposites, they become partners, two aspects of a single algorithmic process, order providing stability, chaos providing variation, together producing the richness of forms you see in nature. When you hold this view, the universe begins to invite a specific kind of feeling, not anxiety, not dread, but awe. Awe at the fact that simple rules can produce such intricate beauty, awe at the way information flows through everything, awe at the way local interactions give rise to global patterns, from atomic lattices to spiral galaxies, from neural networks to ecosystems, from the microstructures of space-time to the macrostructures of the cosmic web. Awe that you yourself are part of this pattern, a local configuration of atoms and fields, organized by the same laws. Emerging from the same code, yet capable of reflecting on that code, capable of asking why reality feels as it does, capable of resting in wonder at the fact that anything exists at all. This perspective does not demand belief. It does not require that you accept every speculative detail. It simply offers a gentle lens, a way of seeing the world as a coherent algorithmic pattern, neither hostile nor comforting by design, but steady, dependable. A universe that behaves the same way today as it did yesterday, the same way here as it does in distant galaxies, because the code does not change. The constants do not suddenly shift. The rules do not unravel. In that constancy there is safety, a background that holds you, a structure that lets stars burn, planets form, life arise, and lets you close your eyes, listen, and drift. As your thoughts grow softer, as images start to blur at the edges, you can imagine the universe's code as a slow, rhythmic pattern, not a harsh clockwork, but a gentle pulse, like waves rolling onto a shore, like breath passing in and out. Each step of the underlying algorithm bringing forth a new configuration, each configuration giving rise to the next, each moment connected to the one before and to the one after, by rules that are simple enough to be written compactly, yet powerful enough to generate everything. Nature as an unfolding code, reality as an algorithmic pattern, and you, for this brief interval, a small conscious eddy within that pattern, free to rest, free to let go, free to dissolve back into the larger flow, while the universe continues its quiet computation, calm, unbroken, serene. There is a quiet symmetry between the universe around you and the universe within you, a symmetry made not of shapes or colors or textures, but of information. Just as the cosmos unfolds from patterns of quantum rules, your mind unfolds from patterns of electrical signals, each neuron firing in response to microscopic changes, each signal carrying its own meaning, each moment of awareness arising from the flow of encoded information. To drift into this idea is to feel how deeply connected you are to the fabric of reality, not figuratively, but literally, because both the cosmos and the mind are systems that process information. Both evolve according to rules, both transform patterns into new patterns, both create meaning from quiet signals moving through networks, the universe through fields and interactions, your mind through synapses and pathways, both complex, both emergent, both grounded in the same silent logic of information. Perception itself arises from this logic. Every sound you hear, every point of light your eyes receive, every texture your skin senses is translated into electrical code, streams of signals traveling through neurons, sorted, filtered, combined, forming the world you believe you're seeing, even though the raw data is only voltage, frequency, timing, patterns. The mind never receives the world directly. It receives information about the world and builds an internal model, a quiet reconstruction of external reality, much like a computational system, not artificial, not mechanical, but biological, fluid, alive. And this realization brings a soft calmness, because it means your entire experience is a continuously updated pattern of information, a gentle stream that flows moment by moment, guided by the rules of your nervous system. In the same way that the evolution of the universe is guided by the rules of physics. The brain's code is not binary, not digital in the strict computer sense, but it is still a code, a living one, based on timing, synchrony, firing thresholds, chemical gradients, all forming a sophisticated language spoken in the silence of neural matter, a language that describes the world, inside and outside, with exquisite nuance. Thoughts are not solid objects, they are patterns, waves of coordinated activity, electrical traces moving along networks, stored not in single neurons but in relationships, in the way one firing pattern leads to another, in how signals echo across pathways, settling into shapes that correspond to memory, to meaning, to recognition, to understanding, all encoded within the rhythms of the mind. Dreams are the gentlest expression of this informational world within. In dreams, the brain continues its pattern-making, but without the constraints of external sensory input. It weaves its own imagery, its own landscapes, its own narratives, not because they are random, but because the brain is a generator of patterns, a system that constructs meaning from signals, even when those signals arise from within itself. In dreams, the mind explores its own informational terrain, pieces of memory recombined, sensations reinterpreted, thoughts mixed together in ways that feel fluid, weightless, unanchored from the physical world, yet still obeying the same fundamental rules of neural computation, rules that create stories from fragments, that create movement from stillness, that create worlds from signals, just as the universe creates structure from the flow of information. There is a quiet parallel here. The universe in its deepest description is a web of information, encoded in fields, entanglement patterns, boundary surfaces, always updating, always evolving, always processing the correlations that define its state. And the mind, in its quietest state, is also a web of information, encoded in neural activity, in synaptic strengths, in transient networks that light up with soft electrical pulses, always changing, always reorganizing, always forming patterns that give rise to awareness. The cosmos and the mind are not the same, but they share a structural resemblance, two systems that take in information, transform it, and produce new states, new structures, new experiences. The universe produces galaxies, your mind produces thoughts, both following their internal logic, both expressing the rules written deeply into their foundations. When you rest in this awareness, you may feel a quiet connection to everything around you, not mystical, not symbolic, but structural. You are made of the same fields, the same particles, governed by the same laws, held together by the same interactions, and guided by the same flow of information. Your thoughts are patterns in your neural network, but those neurons are patterns in molecular chemistry. Those molecules are patterns in atomic structure. Those atoms are patterns in quantum fields. Those fields are patterns in the informational fabric of space-time. Your entire being is a cascade of patterns, one layer emerging from the next, each layer built from the same informational logic that shapes stars and galaxies. And in this recognition, there is peace. Not a peace that asks you to forget, but a peace that comes from understanding. That you are not separate from the order of the universe. You are part of it, a local expression of the cosmic code, a small region where the universe has folded in on itself and become aware. As your thoughts slow down, as your mind drifts gently toward the horizon of sleep, you can imagine the informational world within you softening, patterns becoming lighter, looser, waves of activity slowing, oscillations sinking gently into deeper rhythms. Your mind moving from active processing into quieter cycles, where signals spread softly and the boundaries between inner and outer, between self and world, begin to blur. This is not an absence, it is a gentle transition. A shift from conscious construction to dreamlike wandering, from analytical clarity to imaginal flow, from structured perception to free-form pattern-making, each phase guided by the same informational principles, quiet, precise, and deeply calming. The universe holds its structure as it evolves, and your mind holds its quiet as it drifts, two expressions of the same subtle truth, that everything that unfolds, unfolds through patterns, through information, through the gentle transformation of one state into the next. And as you rest, you become part of this flow, a small, beautiful pattern in a vast informational cosmos, carried gently towards sleep, held softly by the rules that guide everything. From the dance of galaxies, to the whisper of neurons, to the drifting images that will soon rise in your dreams. In the quiet hours of the night, when thought grows light and the world softens at the edges, you may begin to sense a deeper stillness beneath everything, a calm foundation that holds the universe in its gentle structure, a foundation made not of stone or substance or solid matter, but of information. Not the information found in words or symbols, but the information woven into reality itself, in the way particles interact, in the way fields ripple, in the way space holds its shape from one moment to the next. It is a foundation so subtle, so pervasive, that it disappears into the background of every experience, yet it is there, quietly sustaining the entire cosmos. You can imagine the universe, not as a mechanical object, not as a machine, but as an informational ocean, vast, tranquil, ever-present, where every particle is a small wave, every galaxy a drifting current, every beam of light a ripple moving softly across the surface. The ocean is not made of water, but of structure, patterns of entanglement, patterns of geometry, patterns of meaning encoded into the deepest levels of existence. If you listen gently, you might sense the quiet rhythm of this informational sea, not in sound, not in sensation, but in the feeling that everything is connected, not metaphorically, not mystically, but structurally. Everything in the universe is tied together through the laws that govern information. Those laws create continuity. They preserve identity, conservation, coherence, allowing atoms to remain stable, allowing stars to burn consistently, allowing galaxies to form spirals of luminous dust, and allowing you to drift slowly toward rest. Every particle is a whisper of code, each one a tiny expression of deeper rules, rules that determine how it may move, how it may interact, how it may evolve, rules that never break their quiet logic, rules that ensure the universe unfolds with elegance and order. When you hold an atom in your mind, not visually but conceptually, you are holding a small region of this cosmic information, a place where quantum states encode possibilities, where the structure of reality takes shape from correlations, where the laws of nature are expressed in perfect quiet. An atom is not merely matter, it is meaning. A stable pattern because the universe keeps its information consistent, moment by moment, allowing complexity to arise, life to grow, consciousness to emerge, and calm to settle into your thoughts as you rest. When you look at a star, or imagine one now, you are witnessing a luminous pattern in the cosmic algorithm, a region where gravitational logic, nuclear fusion, radiation fields, and quantum statistics all converge into a single brilliant expression. Stars are not accidents. They are solutions to the equations of the cosmos, stable configurations that arise when the rules of physics are allowed to run for long enough, just as crystals form from the rules of chemistry and thoughts form from the rules of the brain. A star is the universe performing its code, a glowing result of informational laws executing themselves with infinite patience, producing light, heat, structure, and beauty. And that beauty is not separate from you. You are made from the remnants of those stars, their atoms, their patterns, their informational structures, now woven into the neural fabric that carries your thoughts. You are stardust, yes, but more precisely, you are star information, a continuation of the patterns that once burned in ancient light. The cosmos is not random, nor is it rigid. It is consistent, a quiet unfolding of mathematical relationships, an ever-evolving tapestry, woven from rules that remain stable, predictable, and elegant. This stability is what allows galaxies to form threads across the universe, what allows planets to orbit steadily, what allows molecules to bind, DNA to encode life, an awareness to arise from the interplay of neural signals. It is the same stability that allows you in this moment to breathe softly, to let your thoughts settle, to drift through the informational ocean that holds all things. As the night deepens, you may sense that you are not separate from this cosmic structure. You are inside it, made from it, sustained by it. Your mind a small eddy in the great informational flow, your thoughts patterns within patterns, your awareness a temporary beautiful formation, arising naturally from the laws that guide everything, from quarks to stars, from synapses to galaxies, all woven into the same quiet consistency. You are not outside the code, you are part of its expression. You are not observing the universe, you are participating in its unfolding. You are not a spectator, you are a chapter in its algorithm, written in stardust, electrical patterns, and memory that drifts softly through the night. The wonder never ends. Even in rest, even in the gentle stillness before sleep, the universe continues its quiet computation, carrying galaxies forward, carrying atoms onward, carrying you deeper into calm. Nothing is rushed, nothing is forced. The cosmos moves in its own rhythm, slow, steady, eternal. A rhythm that holds everything, from the faintest quantum fluctuation to the brightest burning star. From the structure of space-time to the drifting boundary between waking and dreams, all part of a single cosmic lullaby, soft, endless, and deeply serene. And as you rest now, you can let the quiet of this informational ocean carry you, gently, into the deepest calm, where thought becomes light, where awareness softens, where the universe's code fades into the background, and all that remains is peace, a peace that comes from understanding that the universe is consistent, that you are part of it, that everything around you is woven from the same rules, the same patterns, the same quiet logic that guides all things. You are safe in that logic, you are held in that structure, you are surrounded by order and carried by the quiet infinite code of the cosmos. Let it all fade slowly, softly, into rest, into silence, into dreams, where the patterns of your mind will drift gently, echoing the patterns of the universe. Both written in the same endless language, both unfolding in the same eternal calm.